So we've looked at the first couple examples of limiting reactant questions, but I'm afraid to say there is actually one more thing they can do to make it even slightly harder than that. And we're going to look at that in this video. What I mean by slightly harder is just how they express the equation for the particular question. The example I'm going to look at in a second is example on page 9. This one with MgOH2 and HCl going to MgCl2 and H2O. I'm going to explain why it's trickier in a second, but I'm going to make another wee analogy just to introduce a slightly trickier type of question. If again I assume that after I escape this lockdown, I decide I don't want to be a teacher anymore, instead of working in a bun factory, I might go and work in the glider factory to make some gliders. So what my production line will look like here is slightly different. If I'm trying to put together the last step of making a glider, I might have a couple of bus bodies here. Again, hope you appreciate my artistic skills. Clearly 2 glider bodies there. And if the other part of my production line has 7 wheels, okay. For argument's sake, I know it's probably not true, but let's say a glider needs 4 wheels to be a complete glider. So my question is now, how many complete glider buses can I make from 2 glider bodies and 7 wheels? Now, this is slightly tricky in the first example I looked at because, as you can maybe appreciate, it's not a 1-to-1 ratio for wheels to buses. So you need 4 wheels per bus. So you need to take that into account when I'm actually working out the number of complete buses I can make. Hopefully it's not too far beyond you to work out. I actually, between these 2 things, or 2 types of thing, I can only make 1 complete glider bus. Because if each glider needs 4 wheels to be complete, I can easily make 1 because I've got 7 wheels. But once I've got that done, I've actually got 3 wheels left over. And that 3 wheels together can't actually go there to make another bus because I'm missing 1. I need a set of 4. So in this type of calculation, it's a little bit trickier because what actually ended up being true is that the limiting reactant, which was the number of wheels, was actually the reactant I had more of. I had 7 wheels and 2 bus bodies, but I have to take into account the number of these I need per bus to work out which one's limiting. The actual bus chassis at the end, they were excess because I had more than enough of them to do the reaction. I didn't have enough wheels to complete the process there. So if we kind of keep that in our head, let's look at this actual real example involving magnesium hydroxide and HCl. It doesn't look too different on face value. You still got an equation, and we still got 2 masses, which is what we're expecting in a slightly trickier limiting reactant style question. So I'm going to just start as I normally do. I'm going to make my wee table. And again, like before, I'm going to fill my ratio. Now, the key bit which tells me this one's slightly trickier, the ratio is not just 1 to 1 to 1 to 1. It's 1 magnesium hydroxide to 2 HCls to 1 MgCl2 to 2 H2Os. So within this question, I'm trying to work out the mass of magnesium chloride made. I know I'm covering it up, it says that down the bottom of the question. So this is the mass I'm trying to work out, the magnesium chloride. The 2 masses I'm given the question is I've got 50.6 grams of MgOH2 and I've got 45 grams of HCl. Therefore, in this particular question, the H2O at the end doesn't really matter. They're not looking for it, just looking for the mass of magnesium chloride. The start of this question isn't any different to what we did before. Always our instinct should be, if I've got a mass of something, I can convert it into moles, and that will always be worth a mark, even if you get stuck later on in the question. So magnesium hydroxide, 50.6 grams, I need to work out into moles. Moles equals mass over RFM. So I need to work with the RFM first by adding up the masses. The mass is just of magnesium, 2 oxygens, 2 hydrogens, 24 plus 16 plus 16 plus 1 plus 1 is 58. So if I do 50.6 over 58, I end up with the slightly ugly number 0.87. Going to do the same thing for my HCl. 45 grams divided by the RFM of HCl. Now be careful, obviously, the big number here is only for balancing, for the ratio. It's not part of the formula. So the formula is just 1H and 1Cl. So that's 1 plus 35.5, which is 36.5. So if I do moles equals mass over RFM, 45 divided by 36.5 ends up being 1.23 moles. So here's the tricky part of this question. I again have to work out for my product which one of these two columns is the limiting reactant and the excess reactant, because remember, the limiting reactant controls how much product I make. This is trickier because it's not a 1-to-1 ratio. It's a bit like the glider example I looked at. I have to take into account the ratio of how these things interact with each other. There's no kind of easy or like really mechanical way of doing this. It's kind of a wee bit of a thought process, a wee bit of logical thinking. The easiest way I can think to try and explain this is this process here. What I do is when I'm trying to work this out, I pick one of the mole values. It doesn't actually matter which one, I can do it with either. I always pick the left hand one. And I do a wee thought experiment in my head. If this MgOH2, 0.87 moles of it, fully reacted, so in other words was always completely used up, how much of the HCl would I need? So I'm ignoring the fact I've got this 1.23, just how much would I need just looking at 0.87 moles of MgOH2? So what I need to do is look at the ratio of MgOH2 to 2HCl. It's a 1-to-2 ratio. So if I'm working out how much HCl would be needed to react with this 0.87 moles of MgOH2, I need to look at twice as much HCl because it's a 1-to-2 ratio. So if I show you what that looks like, if I had 0.87 moles of MgOH2, it would react with this number times 2, 1.74 moles of HCl. So that's hypothetical. So if I wanted that to all disappear, I would actually need 1.74 moles of it. At this point, I look at what I actually have. I've only got 1.23 moles of it. The implication of that is I don't actually have enough HCl to fully get rid of, fully react with all the MgOH2. So if I don't have enough of a particular reactant to work out, or to react with the other reactant, it's actually limiting the process, and the other one will be excess. So it might be a wee bit hard to follow, so I'm going to actually explain it again. I said at the start it didn't matter which one you pick, so I'm going to do the same thought process with the HCl. You actually only need to do it once. So if I look at the HCl, I'm going to do the same thought process again. If I imagine that this one is fully reacting, I need to think, well, how much of the other reactant do I need to do that reaction with? In this case, it's a 2-to-1 ratio, so it's half as much MgOH2 as HCl. So if I had this fully reacting, the 1.23 moles of HCl, I'm going to divide it by 2, and that would tell me that it would react with 1.23 divided by 2, 0.615 moles of MgOH2. So let's compare that to what I actually do have. I need 0.615 moles of MgOH2 to fully react with this amount of HCl. In reality, I've got more than enough of it. I've actually got 0.87 moles again. If I've got more than enough of one of the reactants to fully react the other one, that again would confirm that this is indeed the excess reactant. And because this one's all going to get used up, it's still the limiting reactant. So what I mean by showing you that is, it doesn't matter which one you look at, you can do the same analysis with either one of the reactants, you will get the same answer each time. The key step is working out, if you pick one of them, how much would you need of the other one, and that allows you to pick which one you got more than enough of, which one you've got not enough of. What I'm saying again, this is quite tricky, is if you look at the numbers there, if you didn't fully understand that step, you wouldn't expect this one as the limiting reactant because it's actually the bigger number. But again, taking into account the ratio of how they react means it is actually limiting even though it's bigger. After all that discussion, you're now going to finish off the question, which is not actually as hard as what you've just done there. The key step is I pick the limiting reactant to work out the moles of the product. I ignore the excess reactant. So that MgOH2 I don't actually need anymore. I need to use my limiting reactant moles here to work out my ratio for my product. Have to be careful here though, it still is a ratio. It's 2-to-1. So I need to divide it by 2 to work out the number of moles of MgCl2 I'm going to make at the end. 1.23 divided by 2 is 0.615. So according to that ratio, I'm going to make that amount of MgCl2 from my limiting reactant. And then I'm very close to the answer. I just need to convert back into a mass. Therefore, I need to use mass equals moles times RFM. RFM of MgCl2 is just 24 plus 35.5 plus 35.5, which is 95. So timesing those two numbers together gives me a final answer of 58.43. So again, I don't know how clear that is, just saying over video. It is a hard type of calculation, but as long as you do a wee bit of practice with it, you will kind of get it into your head. One wee exam tip though, just to give you at this point, if you follow the simpler style of limiting react question, which is in the previous video, you can still apply it to this if you get stuck. What I mean by that is, if you're happy that you always convert all your masses into moles and pick your limiting reactant, if you find this step hard to talk through by picking which one's limiting, which one's excess, when it's not a 1-to-1 ratio, if in doubt, what I would just say is just pick the smaller one, because even if you pick wrong or guess wrong, you're only going to lose 1 mark for the rest of the calculation because your error gets carried forward. So obviously try your best to understand what I did there with the taking the ratio into account to work out which one's limiting and which one's excess. But if in doubt, pick the smaller one as limiting and use it for the rest of the question.